In this video, we're going to discuss angles of elevation and depression and how we can fit those trig ratios to this kind of picture of an angle of elevation or depression. So given this image, the angle of depression is always looking out and down, and the angle of elevation is looking out and up. What we're going to do is fit a right triangle to this image. The most important or most key aspect that I want you to get out of this image is that the angle of elevation is equal to the angle of depression. And there's a past geometry concept, and if you don't remember it, that's okay. But it's the idea that alternate interior angles are congruent, or that they're equal to each other. Because of that, the angle of elevation equals the angle of depression. So it's important to note, if you are given the angle of depression, switch it to the angle of elevation. So we're going to take the angle of depression, put it on our diagram, and we're going to switch it to the angle of elevation. And you'll see what I mean by that in example 2. So let's look at an example. Here it says, a sailor is looking at a kite. If he is looking at the kite at an angle of elevation of 36 degrees, and the distance from the boat to the point where the kite is directly overhead is 40 feet, how high is the kite? If you see the terms angle of elevation or angle of depression, we're going to fit them to that previous diagram. So I'm going to take this diagram, and I know the angle of elevation must be this angle, 36 degrees. So we're going to fit a right triangle to this picture and use some right triangle trigonometry. It tells us the boat to the point where the kite is directly overhead is 40 feet. So let's let this be our boat. It's looking up at our kite. The distance from the boat to the point where the kite is directly overhead is 40 feet. We want to know how high the kite is. That is the kite's vertical height above ground level. So let's call that x. So we use the words to complete the diagram. We fit those specific side lengths and angles as they're described in the word problem. Now using 36 degrees, x is the opposite, 40 is the adjacent, so I'm going to use tangent. Tangent of 36 equals x over 40. We're going to cross multiply. 1 times x is x equals 40 times tangent of 36. Using our graphing calculator, that will give us 29.0617. And since the units are feet, we want to include that. This is 29.0617 feet. That's how high the kite is in the air. Here we have an angle of depression problem. Anytime you see the term angle of elevation or angle of depression, we're going to try and complete this diagram. The angle of depression will always be this angle here. It tells me that this is 17 degrees. Okay, we've got two different buildings, so let's fit our buildings where a clothesline is connected. So let's say here's one building, here's the other building, and we're connecting it with that clothesline. So we've got our right angle here. It tells us the clothesline is 10 yards long. we want to know how far apart the buildings are. So let's call that x. Anytime you're given an angle of depression, we want to switch that to the angle of elevation because they are congruent. They're equal. So I'm going to take that 17 degrees and switch it down here. So now, using those side lengths, x and 10 with 17 degrees, x is the adjacent, 10 is the hypotenuse, so we're going to use cosine. Cosine of 17 equals x over 10. Put that over 1. 1 times x is x equals 10 times cosine of 17. X will equal, entering that in our graphing calculator, 9.563, and the units are yards. It's very important when dealing with angle of depression problems. Make sure you use the correct angle. This is the angle of depression. Then switch it to the angle of elevation.